how to follow this online workshop. So this workshop is actually having the following hands-on. The first is what you're seeing right now is the workshop briefing video, this presentation, and there will be the slide to download and view. So the slide that about the video that you are looking right now, and there is a workshop learning video set, which is actually the playlist in the YouTube, and it will be an archive files contains of the work files, setup tools, and the examples hands-on for the Shellcode workshop basics. It has so many files for there. You will see the overview after this. And last one is the Q&A Slack channel for this workshop is already set up. So for the questions and how to reach me to ask questions, please feel free to ask over there. So following this examples, and you can watch the video, which is part of the example file that being used. Mostly file names in the example is having the naming of the FIRSTCON, but it doesn't mind about that. You just have to follow the video and go to the archive files and then pick up the sample, and you can analyze that for yourself. Or you just want to learn about how this Shellcode works, you can just read about the analysis result, which is provided in the archive files. So anyway, whichever is working for you, feel free to do so. So all you have to do is joining this Slack and go to the R2-SC-basics, and you will see myself over there, and you can check it out for the passwords, and then you can ask as many questions as possible in there. I love to start everything with the definitions. This is the way I'm learning things, and then because it is working, you probably will be best for you too. Well, Shellcode is a sequence of bytes that represents assembly instructions, and that's it. If these instructions of the assembly codes is being saved in the a certain medium that enable executions, it can be executed. That is actually the definition of the Shellcode. And probably you wonder why the name is a Shellcode. So historically, it is firstly coded to return a remote shell when executed. So when the first Shellcode was invented, it'll return the shell environment of the any kind of the devices or OS that being exploited, right? So that was why the name was a Shellcode. I'm only speculating this. I don't have the actual evidence about this naming stuff. Then it meant to run into the executable area to run a desired task. So it has to run. So you cannot just write the garble of the data code or junk code and call it as a Shellcode there. It has to run. It should run. And if it is put in the desired executable area, it will run a desired task, specific task. So Shellcode works in the very small area in the memory because of the size is has to be small. Well, if you compile any executables and then you have the file, right? And then if you, well, in any kind of the executable files, it will be a header stuff. It will be some informational stuff, sections and so on, which is not actually, well, it is needed, but actually when the program is run in the memory, we don't need those kind of the information anymore. those informations probably will be needed before the executable started, or to provide environments or specific details needed for the programs to run. So in the shellcode, you have to be sure that this assembly code will run in a specific area, in the specific conditions, that the stuff that details that you know it better, and then you have to make sure it will run just like that. And it doesn't need anything else, like loading some kind of library there, and then well, it loads libraries, but not as complicated as many kind of the big programs that we are making in the daily basis. So it used to be false, smashed, and as invisible as possible. So shellcode works in a very small area in the memory to fit in. And mostly, not necessarily always, is used for exploitations process. Well, okay, since the size is small, and well, based on the appearance itself, practically shellcode is used mostly in the exploitation processes that we are seeing today. But there are software also that is using the shellcode method to load their parts of the components too, or to download some things, those kind of possibility. So I'm adding this not necessarily always used for the exploitation. This is actually the fact that we have to realize. And shellcode has a dependency to obtain and use its environment functions to perform its tasks or objectives. So it will use the environment, either functions, syscalls, or other ways to make it runs according to what its purpose or what it is designed. So it will utilize anything that can be accessed in the kernel space. For example, it will utilize any kind of the library that actually needed to run to performing their tasks. For example, as a downloader, for example, as to execute some kind of the malicious data in a certain area, or anyway, anything can be done. So shellcode bytes or codes cannot be executed as per binary or command line without additional setup. This is the most important things that you have to understand. If you are seeing a shellcode, probably you will see either first the sample or artifact, which is a binary file, and not saying that is an executed binary file, but just a binary file. It contains the executional code over there. Or you will see it as the blob of the hexadecimal strings in the, for example, exploitations POCs, or any kind of the shellcode sharing websites. It can be done in the two ways. Depends on the compiler that you're using. In myself, for the string stuff, there is C codes to compile that can be used for the either Windows, Mac OS X, or Linux, or any kind of the Unix platforms. And there is also the assembly templates of the shellcode to make it to run, which is a needed assembly way to write it, those hexadecimal strings into a certain format to make sure it will run after the binary is compiled. And for the binary itself, it cannot be run, so either shellcode has to be injected into the memories, or it'll need the wrapper to be compiled first into a certain binary executable files and run it, or load it to load it from another program and then run it to the memory. That can be program, can be anything, like you can imagine scripts in many kind of languages, from the Python, from the VBA, Java, JavaScript, anything. So for executable shellcode itself, it looks for the this is actually the process injections kind of work. Make sure that the instruction pointer is pointing to the top of the place that you want to inject, overwrite, or adding the shellcode into, and then following with anything that you want to receive from the stack, for example, and execute it, reactive the EIP from the suspend mode into an active mode again, and then the shellcode will be actually executed in the memory space. If you want to see more details about that, you can see about my previous presentation in the Hacklu about the process injection in Linux. And in Windows system, it's usually firstly seeks for the kernel's base library and utilize any kind of the API that can be provided from there, and then gets the functions or address desired to utilizing those API to perform its operations, because of the reasons that I'll explain after this. So why we have to learn about the shellcode? There are so many reasons about that. If we want to break it down, so we have to see, we want to know how it works. Why? Because we want to know why it can be started or executed actually. Why? Because we want to learn how to prevent it if it is that harmful. Then we want to do that for hardening and improving our security, right? And we understand that the shellcode is always be there. You have to understand that. So it is very important and crucial for you to know about this knowledge. And there are so many shellcodes and source codes shared in the many kind of repositories around the internet, making it indecent, making it very easy to access, and many kind of the usage, indecent usage, improper usage, dangerous usage is just unavoidable. So more than that, we are also right now having many kind of the exploitation tools and post-exploitation tools that being used by the not good people, and mostly these kind of the frameworks or tools are using shellcode as a stage to inject or to perform task payload and so on. The more you know about the shellcode basics is quite good for you for the handling the next stuff. Shellcode can work in any kind of the operating system and platforms, so it has to be designed specifically to what kind of the operating systems, what kind of the device, what kind of the victim that actually the attackers would like to run this kind of shellcode. It has to be some understanding about those kind of the informations. So the target is quite wide here, from the endpoint to servers, from the IoT to mainframes, and it is not only aiming for the IT but to OT or ICS too. Shellcode evolves as fast as the OS security evolves. We need to keep up with the recent shellcode developments, tools, and frameworks. Well, for the target itself, It can be operating systems being targeted, or your browsers being targeted, or any kind of software that is having some vulnerability that can be exploited. So for example, any kind of the device, saying like iPhone, it has some apps probably that is not so good in the security, and the attackers knows that, and they know that those vulnerability can be triggered through the any kind of the object that can be downloaded from the internet. And then when the object was actually designed for that and being downloaded on the victim side, so probably that object is having the shellcode, and that shellcode can be executed, so probably that iPhone can be compromised too. So that is that important about the how the shellcode can be affected to our life in the security and security activities. So this is why we have to learn about the shellcode. Practical summary is well, shellcode purpose is to gain shell or command or invoking an executions, like a load, and like loading something or executing something or any kind of the things. As a loader or downloader or further intrusion stages, shellcode has to be fileless, and the purpose for that is leaving no artifact traces. Well, obviously, because of most workspace of the shellcode is going to be in the memory. If there is a shellcode activities, they are mostly using socket in the form of the any kind of sockets, a file socket, internet sockets, pipes, kind of the sockets, or many things. Then those sockets is mostly invoking the operating systems kernels, or kernels relation to the device that can be exploited, can be used as the way to exploit. Like in the Cisco, for example, write, connect, and the pipe, or some executions. The way that we are collecting shellcodes for the analysis is we have to know about the post-exploitation frameworks, for example, Empire, Cobalt Strikes, Metasploit, or others, and exploit and also injection tools. You can also collect shellcodes from the shellcode database, and which is can be self-generated, and you will need to have this know-how present in the workshop. You will need a compiler, linker, and disassembler for that, and those adversaries activities are very important for us to monitor if we want to really know about how the shellcode is actually being used nowadays. The way to do that is you are going to be quite a bit active or provided sometimes in your life for the cyber threat intelligence. The other is sources for the shellcode can be followed in the internet, like your monitoring the exploitation and post-exploitation development sites, and you learn and read about the vulnerability POCs, and you think it has a shellcode in it, you just crop the shellcode and try to make a experiment or testing it. And you can see the red teamer toolings or resources, and get some new information about the shellcode that probably will help you for your understanding about the recent development. The basic knowledge needed to learn about the shellcode is addition and understanding about the CPU architecture and assembly language, also C, and knowledge about the kernels, how it works, and what kind of the functions in the kernel that can be executed directly or indirectly, and if indirectly, how it can be executed. what kind of the stuff that actually prevent us to execute something in the kernel and so on. And we have to understand about the OS operating system's usage of the randomized stack or address space and etc. protection mechanism that prevent us from executing our shell code. And we have to know how to use compiler, linker, disassembly, assembly, any kind of the binary tools that can help you to do that, and development tools also to reproduce and to build yourself, to understand it better. Well, many people are asking about why we have to build it. Well, if you don't know how to build it, so how would you know about this kind of shell code is coming from this kind of the builder, for example, this kind of the people who want to build it, for example. By seeing how it's built, you can understand but what kind of the environment that is actually those shell code is being origin from somewhere, someone, some places. So any kind of the details is helping with investigations. So using a good disassembler tools or binary analysis framework that can support analysis in multi-platforms and multi-architecture will be helpful. And it will be good if that software you are using is supporting the automations. For example, rather is supporting for all of the CPUs and can support all of the scriptings and supporting to work in many kind of the installation native in the multiple OS. And having a know-how to perform a static analysis, dynamic analysis, emulation analysis for an executable code. Remember, this is not only about the malware, but can be a goodware too. But the way to think about those are the same. So you have to know about how to perform the static, dynamic, emulation analysis, and you need to have the experience to debug a process or a software or running some tasks. First, we will talk about the theoretical way to make a shellcode itself. In the old school shellcode, well, when it is coded in the Linux environment, it will need a compiler, which is a GCC, and we'll need a linker, which is probably many of us are using LD, and we have some kind of the assembler compiler too. Anything that can be used for that. In my case, I'm using the NetWide assembly, which is I'm using it also for this workshops, and there is also ObjectDump. These tools are still valid until now, and you can use it for any kind of the shellcode operations. So for the creation shellcode analysis environment, the environment for the operating system for the shellcode is exactly as per how the operating system for the shellcode to run. It is gonna be a different between different setup for the Linux and the Windows. When in Linux, syscall is mostly called and actively accessed by shellcode after the such kind of the exploitations for the kernel is or executables to access those memory restricted memory area has been performed. In Windows, the shellcode can first only target the API of the kernel libraries loaded in the beginning. There is a init order for that, and then it went to accessible API and aiming for its functions to perform operations to any kind of the desired systems, and then after the base API for loading another library can be established, any kind of the operations can be performed in the Windows environment. So in Windows cases, the coder should recognize and extracting the memory address, and then making sure about what kind of the kernel init modules will be loaded, and then what kind of API that actually can be used by dumping all of those informations from the simulations of the target systems, and then making some kind of the calculations about how is possible for a function name of an API can be seek under specific libraries. And after that, the shellcode can be performed and being used. In Linux, the coder will plan the workarounds to inject or execute shellcodes to avoid the restrictions, for example, stack protections, or SE Linux, or any kind of the stuff like ALSR, for example, to make sure that the executable code design can be run over there. So we have static analysis for the shellcode. That is one operations that really you need to know about. It is a way to dissect any kind of the shellcode with similar to the static analysis in the binary analysis, without the executions of the shellcode itself. The binary tools will help you to read the binary files, or the binary bytes, or we call it the opcodes, the instructions opcodes, bytes of a shellcode. And you can reading it by the assembly, or you will need help from any kind of the compiler that can make you easily reading it, and to make you understand about what logical calculation that has been made to make the executional steps of the shellcodes can be done. So a good binary tool can help you to identify the type of the environment needed, and to help you but many kind of the operations, like which system calls that actually being used and stuff like that will be hint from your binary analysis tool. And several shellcode analysis tool can be emulated from the limited virtual stack. So probably the usage of the VM is quite good for the shellcode too. But to calculate the complex operations that the eyes cannot keep up, it is quite good to be done. But many of the shellcode also being obfuscated with this having so many kind of the loops or jump, so it will make you giving a huge deal of the lost time too. But emulation for the shellcode is very important, and most of the shellcode that I know, sometimes part of it can be emulated quite well. Rather, is having those functions that making you capable to perform emulations, then in any kind of the OS and architectures with a supported emulation tools called ASIL, ESIL. In ASIL, you can understand about the instructions without executing any kind of the opcodes. And the challenges for that is obfuscation, as I said before, or probably packed code encryptions, or stack protect evasions, and so on. Dynamic analysis for the shellcode is in contrast to the static analysis. Dynamic analysis shellcode is not as different with binary analysis, and all you have to do, but you'll need extra work for that. You have to provide the environment to make sure that it can be debugged and traced. Um, the tracing is gonna be good for you too, to understand about the what kind of the execution details in the kernel levels, for example. And the debugger will help you to analyze and how it actually manipulate the executions to perform its activities. So, like analyzes the any kind of the malicious objects, Shellcode on dynamic analysis is typically executed in a sandbox or VM for monitoring its runtime behaviors. So, do not ever run it in your actually used systems. And rather is having the low-level debugger that can be set to debug executables and analyze them in the real time. The challenges are anti-debug or anti-VM, some injections, and memory executions. Injections, by all means, is probably you'll need another segment of the next stage of the payload, which is you have to fetch that too, which is quite difficult. Memory execution can be anything. You can inject, you can hollowing, you can do many things. And the worst part of the memory execution is you don't have much clue what is going on unless you're having a live system for that. So in this part, regenerations is a must, and mostly people are doing that in the virtual environments, and we know that, and adversaries knows that too. These are the list actually of the video that you can see. Actually we have like a 14 of them, and all of this gonna be uploaded in the YouTube playlist, and it's accessible for you for having a practice and listening or seeing them in your own time. So go back to the environment demonstrations. So the first video is having a good explanation about how you should set up your environments, and it's starting from the Linux first and then goes to the Windows afterwards. And this is quite important basics for all of the analysis that you're gonna do with Rotary for the Shellcodes. It is quite comprehensive explanations, and it has many samples. We're using this Surigi Linux for the Linux, and for the Windows, these are the setups that needed to be implemented into your systems. And then after that, explanations of one by one about how the stuff that needed to be set up. And then started with the Linux setting up, and it has many files, many kind of template that you can use for making a shellcode. Several examples about how to test the environment too is provided in there, and these are the hint that is actually needed for you to make a shellcode running. It is having a good English explanation slowly in there, and this example about how to test the environments, and after that how to test it like that with for example in the S-trace or and so on. And then we are having also another kind of the setup, and this is another test for the ELF with assembly ones, and we can start it also. We are studying about the differences between the setting up for the testing shellcode in the using C wrapper or assembly wrapper. So you will know the differences, and how to set up your system will be explained afterwards, and the requirement that needed to setting up in the Linux is listed over there. And starting to basic about how to view the shellcode, and to recognize the locations of the shellcode in the testing binaries for any kind of shellcode that you'd like to test will be explained in this part. And we can also compare about the source code to the rudder shell over there too. And also we'll see about the many kind of the stuff afterwards. And for the Windows part, we are switching to the GUI and then going to the cell environment of the Windows because of the font is quite bigger. So I'm gonna use this environment for all over the workshop, mostly, but sometimes you have to bear with the folder kind of the viewing. And yes, we are using this kind of tools. This very good one, R-Windows-C, and we are using also the code blocks for the beginner to know about how to compile this Shellcode in the C wrapper. And then this is a R-Win-C demonstrations, and we are having the special template to compile the Shellcode in the assembly types to make executables PE for the analyzing any kind of the Shellcode for the 32 bits, and some testings after being compiled will be presented in there, and also how to set up the Radare as a software. In this demonstration, I'm gonna use the 5.3.1 stable one, and explanation about that too, and how to execute them, how to analyze the first for the first timer, how to figure where is the Shellcode testing that will be implemented in there, and how to debug it, which is very comfortable for you to try if you are new with Radare and just depending on the Windows environment, for example. And this actually the code and so on, and these are the several files being demonstrated. In this case, I'm using the process hacker to make sure whether the connections or the program is actually started or stopping or crash or something like that. And well, this is all about the first video, and in the end there's an explanation about the very good old tool Dumbin that can be used to study about the Windows libraries and to understand where is actually the export address. In this case, you can seek where the RVA or ordinals and the name of the functions API that can be seek. This is actually a base know-how that if you want to dig further to the Windows Shellcodes. So that's gonna be it for the first demonstrations. Okay, now we are finished with the setting up the environment. So we want to try to build the Shellcode by ourselves. In this chapter, we will start with either Linux or Windows first. Then we will use those operating systems for making first Shellcode that actually becoming a good challenges for the beginners. In this environment is 32 bits for each operating systems. And in the Windows, we will try to access any kind of the API that available to be called with the absolute address. And after we are doing that for the Linux and for also the Windows, we will switch further to the Windows because of it needs about the know-how on the how about you are using the API for making any kind of the library to be loaded and to use that loaded libraries API for any kind of use. So in this case, I'm introducing you about how to make a message box. A message box is quite not as easy as we thought because of it'll need you to loading several libraries needed to make the message box A, for example, to be called. And you have to learn about how to make a plan for as per described before. For example, in order to make the message box, you will need to know about the where the message box is located, and in order to do that, you have to make a plan of it. We know that there are message box A, message box W, and we are seeking for the message box A, which is the API that actually resides in the user32 DLL, and user32 DLL is not actually loaded when the any kind of the application is running. So firstly, we'll load the NT DLL, and then we'll load the kernel base and the kernel 32 DLL, and then how it will explain how to get there and fetching this API inside of the user 32 DLL. And for that, in this example, I'm going to use strings seeking methods in order to get us to the user 32 DLL. So we are using user 32 DLL. It will be pushed to the stack first, and then will be saved in the register, and then afterwards we will use the kernel 32 DLL, which is actually already loaded into the init mode start when the actually application is running in the 32 bits in the Windows. Doesn't matter whether your system is 32 bits or 64 bits, kernel 32 DLL will recognize if you are running something with a 32 bits, it will be loaded. And inside of the kernel 32 DLL, it has the API of the load library A, and then you can use the load library A to load the user 32 DLL, and using that with manipulations of the registers, and then afterward you can seek invoke the message box A with get process address 32 DLL, and to get the user 32 DLL's API message box A, and then afterwards you save another kind of the strings that you want to pop up in the message box, and then after everything is set and executables is needed for running the message box A is already in the desired registers, and all you have to do is just execute the message box with the arguments that already pushed in the stacks. So afterwards we can use the know-how that we did before over here, the absolute address, which we can use that for invoking the exit process in the kernel 32 DLL to finish the process. So this is planned. To make it simpler and easy to understand, this is a pseudo code for the C code for that plan itself. In this way, probably some of the you who's involved with the development will know exactly about what we are talking about. So we try to use this, and we try to execute the message box A or W with the get process address, invoking the user 32 and loading the message box. We will load these strings to pop up, and hopefully it will result in stuff like this. So this is planned, and it seems doable. So how about to make this as the shellcode? It will be explained in the next demonstration. So here are the stuff that needed to be done, and there's a video for it, and we'll go to the video right away. I will make again a brief explanations about that, and you have to see the video by yourself, and you have to follow the steps over there and doing it for the exercise. Okay, first we are going to see the video number 002 explaining about the absolute address calling for Windows and Linux. We go to this shell environment and run the video number 2 here. So here we are. We're starting the explanation first with the how to make a message printing messages in the Linux environment, and we try to make a simple printf, and this is the result after being compiled, and we study about how this opcode can be made into a shellcode or not. And afterward, if you're thinking that it's not possible, we just going to the next method, for example, using this a little bit more to the closer to the kernel stuff, like fwrite or flush, for example, that can invoking more library like functions. And we will compile it again, and we will see about the result. And then after the alpha being made, we can see then analyze that oh, this is still including some stuff of library outside of the scope that really need to be loaded. It's not quite good. Then we go to the next stuff, which is performing the syscall for the writing functions. And let's see about the result afterwards. And we compiled it pretty well with a template and the hint that was explained before in the how to make an environment. And then we study about what the result in it, and then we seek that the opcodes is there, and then probably we can do a little bit more changes. For example, the database settings has to be more implemented in the actual closer to the program, so it can be made more compact and small and fit to the criteria of the shellcodes. And in the end, we will have to dwell with the assembly language for that. And these are the how the explanation about the how to make of it. And this is actually based on the what we did before with the write syscall, and then now we just rewrite it again in the assembly forms, and we compile it, and then we'll see about how the result will be. And this is actually the template that being used in the NetWide assembly compiler, and we check about the result of these assembly programs, and we can see now this is actually the shellcode. Stuff like this is being made and being trained for you to understand about how actually to build a shellcode is, and what kind of the challenges that actually happen, and so on. And you can check whether the shellcode is actually working with the emulations, and then we can there is an explanation about how it can work and how it cannot be analyzed through the ASIL or emulations. And there's also several tips for the easy debugging for this purpose. Well, this is actually the way for the compiling it as a shellcode after being decided this is actually the hex code that actually needed to make it as a shellcode. And then first compiled with a C program, and let's see whether it is working. This is the way to build the hex strings that can be used for this C compiler, and then using that in the kind of the wrapper, and using the hint command over here that wasn't explained before in the build environment, because of this is related to the building of the shellcode itself. And after you compile with these options, and then you just copy paste and change the necessary stuff, and actually the file will be made just like that. And then you can check, and you can see whether the shellcode is there, and you can find out where is the object shellcode itself. And it is done with the C wrapper. And then let's dig it further also to the Windows environment. So in the Windows environment, you have to do the most more or less similar stuff with the Windows 1. You have to use several templates that has been provided. In this matter, I'm going to use the assembly template for the compiler and the C wrapper too. So if you want to print the hello in the message box with C programming, and the Windows is quite easy. Demonstrated from that first. But then we will find it is actually difficult to call directly to the message box, because of after several guided investigation will show you the POC that actually the needed user 32DL is not actually being loaded to the memory. And then this is actually how to seek the memory with the route array. And then you can having the understanding about what is the things that can be seen and cannot be seen during the debugging on the Windows in the Radar environments. And after that, you will see about the result about the compilations that you made before, to see actually that the desired functions is actually the imported libraries. And after that, you can see that this is a message box 8 being used, and you will have to load that to the binary. So it's not very good to do the message box for the learning about the building the shellcode from the scratch. So we will use another kind of the method, which is actually being more easily to make as a shellcode. And in this part, we are trying to pick up several functions in here, like exit process, for example, and sleep. So we can use only the kernel's 32 DLL, and we just try to compile it, and then we just try to get where the absolute address of those tools APIs are, and we plan about how to make it executable with a shellcode under the assembly languages. Just write it from the scratch, stuff like that. And let's see whether it can be a sleep and exit process being implemented by putting the absolute address that we seek before with the RVNC, and then let's see whether it can be executed or not. And it has some explanations about this is absolute address is only run on only one time, probably if you are restarting against the operating system, and then the absolute addresses will be changed and so on. So it has a merit and demerit in using the absolute address. And some testing about how to make that. And this is actually the program itself after being compiled, and we are seeking about what the shellcode is actually being coded afterwards. And we try to build that shellcode based on the opcodes that have been compiled in the Windows environment. And we made C code templates, and we are making the assembly codes templates too, that can be used for the wrapper on the compilation and testing the shellcode. This is the wrapper that being used, and we just try to compile that afterwards. And this is for the assembly one. So we have the two stuff that are being prepared, and then afterward we try to compile them one by one. The C starting from the C first, and then we go also with the assembly afterwards. Most of them will be done and will be tested in the process hacker, because of we are just running the program which is only going to sleep and then exit. And both of the result will be tested, and this is actually the first shellcode that you can practice to make in this session. It's quite easy, it's quite entertaining. The point is not making you about the super massive shellcode in this first try, but try to make you being close with the Radar environment and the shell environment that actually can make you operate quite well too over there, especially for the beginners. So these are actually the shellcode that being made, and then as you can see, there are differences with the compilations resulted from the net-wide assembly and C compilers, which is based on the GCCs. GW is a GCCs. So there, it is actually what the presentation is all about for the building the shellcode. But yet we are still seeking how to make a message box, right, in the first place. So in the Windows, so we know about how to make it absolute quotes, but what if we want to use another library which is having another API inside that library to to make a easy shellcode like a message box. Is there any way to do that? Yes, there is. And then in the next video, which is explained in the, let's go to the slide in here. This is actually the first way to make you use another kind of the library in the Windows and use the API inside of it. And the demonstration for that is going to be the file 003. File 003 is this file, so I'm going to run it right now. So as per explained in the plan that in this video, I will explain about how the easiest way to get you the desired libraries using the absolute calling methods. And in this case, we are using the load library ACE, which is will be called through the absolute address, and afterward we are using the exit process too, and then many of them are using the absolute address calling, and how to get the strings to the stacks first, and then afterward you can try to get any kind of the functions names which is can match you to the desired API to execute the desired operations. In this case is a message box A for the executing a message box messages, and how to manipulate all of the data to the stack and goes to the some register for the further usage as a registers. So this is it will be this is gonna be your first assembly program for the cell coding if you never making a cell code before. So I'll try to make a very thorough explanations about that this matter, and by following this videos and understanding about what this actually being done, this is actually the very basic ways that you can make a circle from, and probably in every system the absolute address is not the same, so you have to really check your current existing absolute address, and then you have to compile that again to make it works. And I guarantee you this is all work in the Windows even Windows 10. And after doing this, we will start to testing and making about the explanation on how to actually compile those, and then we try to go to some operations in the radar, which make you understand about how to see the stuff that being compiled after being compiled. For example, if you are actually go to the binary after being compiled in the ELF mode on the Windows system, you can make you can see a very beautiful code that actually being intact and imported as a flag in the radar that can be used for your analysis or any kind of the manipulation of the cell codes later on. And there are some ways to for you to browse the actually a binary after being compiled, and to understand about the which place actually the cell code will be implemented after you compile it in the Windows platforms, and then how to make that if after being compiled to be a cell code, like previously explained. Also like this, you can use any kind of the hex editor to do so, and then afterwards using that binary hex in text, you can use it in any kind of a template that provided. Use the assembly one, and use this is a C code to be used in the C templates, and you just build it. It was built and tested. It is pop up there. Stuff like this is being explained in this video. So for the assembly one, this is a way to compile it, and then the same things happen, and then after you execute that, the result of the compilations, it will be executed there. And we changed the name of the executables with to make sure this is actually the result of binary compiled from the assembly templates, and then if being executed again, it will be run as per it is. So like that. So all are working pretty well. So you can use this as a base operations for the further start. You can use this kind of operations. You can use this method for doing the next step of shell codings, buildings, or analyzing or regenerations in the any environments related to the 32 bits. And there are some examples about that in the Windows, and then also some examples about that in the Linux platforms too. So let's go back to the training brief presentations, so we can go to the next part. So these are the stuff that you really need to know about how to make analysis in Radar for the shell codes that you are facing. First, there are three types of the analysis that can be done in the Radar 2, which are static analysis, dynamic analysis, and emulation analysis. So static analysis is can be done after you understand about how to build a shell code, and probably you want to make some kind of the testing for that. And you can also directly to analyze the payloads to seek what the actual operations this shell code will be, and after that you can deal with adjustments in your systems for making sure about some emulation calculations, for example, or some kind of the patching that you want to make sure that the shell code is doing some kind of the operations with io.cache. io.cache is one environment setting in the radar that making you to not making changes in the binary that you are analyzing, but try to make a temporary space for making any kind of modification, so you will not mess directly with the binary you are investigating. And there is a practical there is a practical shell code analysis in Radar with a dynamic analysis, which is reconstruct the executables, and you can load it by yourself. This can be done after you regenerate the shell code with any kind of a wrapper that you already provided, and try to run it. And then after you analyze it, first you have to make sure it is going to be in a very safe environment, and you have to analyze it statically first into a limit that you can do it, and you just confirm about those operations or the stuff that you don't really make sure about with this dynamic analysis. It is also called as a debugging, and this is where actually you will recognize how the payload actually executed. For the practical shell code dynamic analysis, the most important ones is I'm doing the DFIR a lot, so in my case I try to simulate the shell code, for example, not only to confirm but the operational executions of the shell code itself, but actually the artifacts that can be generated, and what kind of the log that can be triggered to make sure that this shell code is actually leaving a trace or occupying which kind of the space in the memory and stuff like that, which gonna be a good reference for the investigations as reference. And emulations analysis is the usage of the emulator in the Radar. It has a very small virtual machines, and it has a very good logic made by the Conrad. It is called as EASIL. EASIL is emulations analysis in Radar, and then it can be used with you have to generate the EASIL in the environment to make sure about the EASIL calculations can be performed, and then you can also making about the actual stepping, for example, to make sure about some fake register can be used for calculating any kind of the operations, and you can initiate and you can reinitiate the issue afterwards too. These are some operations that actually can be used for the ASILs, or some operations that can manipulate the strings that can be used in the radar array. So two ways. If you want to use the W command like this, we have a WO series, which is for stepping and so on. Not stepping. This is for subtractions, additional, and so on. And these operations can be used for checking about the values or the binaries that they being investigated without messing the real binary, if you are using the IO cache. If you are using the ASIL, it will not touch the original binary or the original environment at all, and the radar will use the fake stack for that, and everything will go to the VM environment for doing any kind of the operations. So these are the big difference between these two. Please be careful about that. Analyzing Windows and Linux shellcodes in radar is different, but practically it is different because of the operating systems is different, and any kind of the tools that you want to analyze Linux in Windows, it has some generic differences. So Linux is well, mostly invoking a shellcode will be spotted there, and I'm sorry, in Linux invoking syscall can be easily spotted because it will trigger any kind of the syscall wrapper or the interrupt that is needed to start the execution of the syscall or the service 0. And we can understand, we need to know know-how about how to seek the syscalls are being used and stuff like that. Rather is having an implementation of some several basics libraries of the syscalls in the database, but you have to also improve yourself also to get much more libraries that can be implemented for your operations. So there are many targets for analyzing in the Linux. It is quite easier than Windows actually, and you can analyze a thread or process, loader, libraries, or kernel, anything that actually running into your systems, but probably you will bump with several boundaries that not allowing you to make some changes, but you can make some adjustment for that. And for that purpose, you have to use the VM for running those kind of the Linux distributions which you want to experiment with. And for the Windows operating systems, and for Windows operating systems, you don't have a direct kernel interface, right? So you have to make sure that you really need to aim the address that they actually invoked for running certain API that actually being used for the shellcode after somehow there were some kind of the operations to load the DLL or libraries like that. And well, mostly most of the shellcode are using the load library A to load libraries, and probably get the proc address for the APIs being used also for executing some libraries, and WinExec, for example, is being used a lot, and for the any kind of the operations related to the network, probably the library like WS32 being used, or probably another library also can be used for the purpose. And mostly in the any kind of the operations, these are actually not much difference with Linux. Function arguments are really safe in the stacks and passed to the registers according to the their API usage conventions in the Windows platform or in Linux, you have to understand about how the syscall or the functions related to such operations will be called. So you have to work very close with documentation for both kind of the usage of the arguments or stuff really needed to run functions. And for that, you have to very careful also about the usage of the register. And then in the complex shellcodes, mostly they are built as the modular in many functions, so it has separated in several modules actually, and then they are calling each other, and then there are so many arguments being passed over there. So, and for executions, probably they are those kind of shellcodes are using EX or RUX for the executions, or probably EBX, RBX, whatever. And then you have to really know about those kind of the trend. And then if you are digging it further to the advanced class in the many kind of the modular shellcodes analysis, you will see a very significant pattern about some executions that can be performed by a specific shellcodes and can be traced from there too. The challenge is mostly R2 static analysis for Windows is being hard with dealing with the obfuscations or some simple cryptographies operations, like mostly use are XOR or AND or ROR kind of operations. And Linux shellcode analyzed in R2 is well, mostly shellcodes are analyzed in the VM environment, right? So in anyway, if the attackers knows that the payload is not running in the VM, probably there is a possibility also that the shellcode is having a simple checking for whether the victim is running VM or not, to avoid the kind of the analysis and so on. Those are the challenges. And for that, we go to the next static and dynamic analysis for the Windows in demonstrations. In these demonstrations, you will refer to the video number 004, and we will see it soon. So in the next demonstrations, it's about the mystery shellcode binary, which is actually being used for this practice for the static and the dynamic analysis in the Windows 32 bits. And this is quite interesting for testing your analysis process or logic in using the Radar 2. And for that, we are using the video in the list number 004. We will start like this and explaining you about the binary in there. This is actually the binary that needed to be dissected here, 003 mystery-ac.bin. So the mystery is quite good, practically explaining you about some shellcode over there that needing to be analyzed, and you have to grab the opcodes first, and then you have to seek how to read the inside of the opcodes and disassembled codes and try to figure how it works, and step by step about how to nail the bug in the RAD array will be performed in the videos. And then afterwards you analyze that and dump the result into the text file here, and afterwards you will be guided to make analyzing for the text files. The text files will look like this after being done, and I was just writing all of the analysis result in there, so stuff like that. And then you will be guided thoroughly until the you know exactly what the steps of the shellcode is doing. So it is practically, the shellcode is quite interesting because of it will pop you the message box with wood messages, and it's a Windows shellcode seeking for the API by loop, and the first loop is try to seek the hash of the load library A in the kernel base.dll, and it uses the load library A to load the user 32 DLL afterwards, and then seek the hash of the message box A, and then break the loops for the searching and seeking after you found those two library being loaded, and then the two APIs already known, and after breaking the loop, pushing the actually strings needed to be used in the message box and into the stacks, and executing the message box A arguments. This is quite simple, and it's quite interesting. It is straightforward, and it's actually becoming a very good reference for you for the dissecting the more shellcode after this. And the presentations in the videos is quite details, so I'm gonna skip several parts, and it's including how about the analysis being made in the statically way, and then afterwards you have to making some how to running it to debug it, and then it will guide you step by step about how to analyzing it through the wrapper, and you compile it like that. And all of the stuff needed is providing to you in the actually folder that being uploaded in the internet. And these are the files that you will actually being seen in the saved in the folder that in the Google Drive, so you can play with it later on. And well, afterwards you just try to compile it to make sure that it is running or not running, and then there are many ways for you to test this binary or that kind of the strings to run in the environments that you are compiling with, to know exactly what it is doing. And afterwards you can just try to learn to doing the dynamic analyzing, how to execute the program after being loaded in the debugging state of the run array afterwards. And then there are several tips that can be done. In this case, you can make sure whether the program is really using the kernel base .dll and not the kernel 32 DLL. Well, it is quite simple because of the EBP is will point to the which library that actually being loaded after before seeking for the user 32 DLL. So you can check it easily like that after you understand the static analyzing for it. So it's quite important that for any kind of the shellcode analyzer to know about the statically how the shellcode is actually operate, so they will know exactly about what to aim and what to confirm and stuff like that, and probably just have to aiming for the new modifications or new implementations that not being commonly used or usually spotted or shared in the internet. Then debugging was going. You'll learn about how to seek those in the memory and try to confirm about where exactly the shellcode is located, and then after being executed in this kind of form, it makes you understand about if you are seeing the system that actually being attacked by the shellcode, and the shellcode is more or less is still there in the memory or being safe in the free space during the forensics. Probably you can seek it, and in the carving then you can know exactly about the location of the those shellcode. So this is quite important, so to understand about what kind of the strings that actually intact. So any kind of the forensics tools like Surrogate Linux or XOS or ENKs can seek it later on. And this is quite important actually to understand about this kind of the code exists in the memory, in which part of it. So if you are handling with hot forensics, or probably you can aim those kind of part of the memory to be analyzed further with, for example, volatility and so on. Then you'll learn about how to debug that and to make sure about the understanding about the concept about the how exactly this shellcode is loading. And it's a quite good, nice, and this depends on the looping. It's only a calling for the executable for the executing the message box over here. It has a one call, and there is another one here to execute the call library A to load the user 32 DLL. Is quite nice, and this is actually good challenges for you. So this is about the video 004. It's quite challenging, so we'll go to the next part. In the next part, we are talking about the Linux operations of the static and emulations analysis for the Linux shellcodes. And for that, you'll have video number 005 that can see in the usual place. Let's switch to the video folder. Okay, here it is. It was 4 before, and then we're going to the number 5. Let's do it. Well, you go to the Sergey Linux for this kind of the operations, and then we are trying to use this example in the Raspberry shared shellcode to be a standard practice of the shellcode in the Raspberry team. So I'm going to share this to you. These are the shellcode actually copy paste from the Raspberry book. We strongly recommend you to read it if you want to master about the Raspberry. And using this shellcode is quite good. So just disable any kind of the options that you don't need it, and then all you have to do is compile it and doing the analysis afterwards. And it is Sergey Linux that I'm using, and then in this part you have to compile it first. After you compile it, you will seek in the binary itself and to seek where exactly the shellcode is located, and then try to learn about how to aim the after compilations main functions, and then the shellcode after being found. All you have to do is analyzing the shellcode itself. So this shellcode is not easily being read because of a little bit obfuscated, and it will explain to you about the usage of the IO.cas for the setting environment to not messing with the real binary, but you can make a kind of the modifications with the data that actually you are analyzing. And it's quite good practice for you to understand about how to operate rather with currently intact tools that help you with any kind of the analysis. And these are the data, and then it has some little bit of obfuscation operations in this area. All you have to do is using the commands that being implemented in the Raspberry that we explained before is a WO, and then we can move forward. These are W commands that can help you to manipulate the bytes, and after that you can implement this after being setting the IOCAS into on first. And afterwards, all you have to do is to make sure which part of the binary to be set in the WO command. In this matter, it will teach you how to calculate the stuff that you need to obfuscate or recalculate the structure of the binary that being obfuscated to be easily being read as per program in the shellcode to avoid the direct reading for it. And yes, after you understand about this and implement it to the function just like that and running it to the specific pass in the binary, and you will see the actual shellcode as per usually as per used to be coded originally. So this is actually the good ways to start the kind of the analysis in the rather way. This is static analysis. Do not get it wrong. All we have to do is just recalculate the stuff and put it into the cache platforms, and then we can analyze further in the cache platforms to make the make sure about what kind of the operations are actually being performed. And this is a quite good example. I want you to understand that, helping you about knowing how to seek the with the syscall and so on. And along with reading it, you can also being guided about using another kind of the implemented functions to make a calculations between the number hexadecimals to decimals to octal and so on. That will help you with the analysis. And it's also I will show you how to make a comments, and then how to dump actually the data that being coded in the hex, so can be seen soon and easily with text hex editor and text viewer in the radar array 2. So the sample will actually was using this kind of the command to make a modification for the your password file. So, and the other commands is also interesting. I'm sorry. And the other demonstration is also interesting, which is explaining you another shellcode that can be used also for the Linux platforms. And this shellcode is analyzed also as per before, compiled first, and then after you compile, you don't know exactly what the main address is, and it can be anywhere, and then it should be here, but you don't know exactly where the EBX here in the static analysis, right? So if using the static analysis and you want to know exactly what the EBX is located, you don't have to debug it, but all you have to do is run the emulation, so you will know more or less about the address of a EBX, and it will be demonstrated in this sample. And this is how you start the ECL, starting the virtual machine, starting to make this position as a base of the tracing, and then the ACL tracing is started from there. And then in this section you will get the exactly locations here. This is actually the address of the main will be located, and you can go there and make your further analysis. Then afterwards you will be guided in that sample to seek where exactly the shellcode is located. And then if you don't know the address, you can do another ACL calculations for making sure about the address of the shellcode itself will be known. This is actually the shellcode, and how to deal with the garbled kind of the assemblies. You can fix them like this. It has a very good tips for that, and so on and so on. So down to the direct statically analyze each command, which having what kind of the meanings, and in the end you will see this is actually the bind cell that will execute the cell bin sh, and it will guide you until the part where actually you can make a demonstrations to connect from the remote for that. It's a very good explanations actually for the Linux shellcode analysis. So this is for the this demonstrations number 5005. So we'll go to the next part. In this part, we go back again to the Windows environment, which now we are talking about the executables in the Windows shellcode. Mostly is using the infamous WinExec API, and WinExec API can be reached with many kind of the ways to avoid the detections, to make sure that we don't know what actually WinExec is called from, and so on. So you have to know certain ways that to make you understand about how to make WinExec being executed in the Windows Shellcode environment. So this is the part for that. And for this purpose, we have a plan like this. So it's very simple. We want to use the WinExec API to execute the calc.exe, the calculator, or shell like a CMD.exe, for example. The plan is easy, just like this, but we want to get to the WinExec in the three ways that are commonly being used in the shellcode nowadays. So we will go to the demonstration, first demonstration, second demonstration, and the third demonstration for each of the methods. And for that, it's gonna be back to the basics that we have to remember about the usage of the rwin.cs, or the usage of the dump bin, and you have to know about the kernel 32 RVA or kernel based RVAs, and how to make a calling about the APIs, how it is located, and then the naming for that. And after you understand those informations, and then you also refresh about the usage of the stacks, and then how the stacks can put the data back to the register, and how those data in the register can be passed to another function or another loop that being actually called. So register are limited because this is 32 bits, and there are many kind of the changing dynamically used values for the register that being used a lot, and so on. Then you have to make sure about that. So firstly, probably in order to get to the kernel libraries, you have to understand also about the PEB, and then goes to the init order and stuff like that. Then after that, you can go in each init module library, like NTDLL, kernel base, and kernel 32s, and then seeking the function that is needed to be run from there. That kind of the information is already explained in the previous videos and explanations. So this is a kind of the implementation for those in order to understand about the execution through the WinExec. The video for Kato. The video for that operations is actually here. You can see it, WinExec 1, 2, 3. These are the video number 006, 007, 008. Each of the video is explaining the different implementation of the WinExec. So all you have to do is listening to the presentations about the briefings of each of videos, and then you have to practice by yourself by watching the videos afterwards. Okay, the first method is we are using the video 006. It is a way to well, after you seek about the PEB and you know exactly what which init order and which kind of library you want to aim, and then you seek the desired API functions and function names strings that being in the kernel's libraries, and then you want to execute the WinExec, and then you want to go to the exit process afterwards. Then in this example, as per seen in this screenshot, you can see that the WinExec, calc.exe, and exit process strings are pushed into stack to be used for this purpose. The video is quite simple. I'm going to run it a bit for you. So this is the video. Well, this is actually the video that I want you to see. Well, this is the plan that we were talking about before, and these are actually the data that being used for this practice. It has 3 binaries related to the WinExec, and we're doing that one by one. And as you can see there, we manually changed that to the many kind of the formats of the hex that can be used for the template compilations of each shellcode to make sure that is it working or not. Then in the sys and the assembly one, this assembly one, then all you have to do is compile it. This is the C templates, and then you put it there, and then you have to compile it with explanation that I explained before. And after that, you probably would like to make sure that is it running or not. Well, compilation is as per explained before, and then if you're running it, it runs. Okay, good. So we are having stuff to analyze then. So this is also the test for the after compilations, and the explanations will go with in the radar environments, which is explaining about what kind of these strings are doing there, and then there are some tips of the analyzing through radar for the shellcodes that can be used for you. And I'm making a manual analyzing and making comments together in the screen, so you can follow that in the videos. And then you can make changes, many kind of the stuff in the radar area to make it sure it is bright enough for you or good enough for your eyes and stuff like that. Some good coloring scheme are there too. And after being analyzed, you can make a study about the what kind of the operations actually being going on over there. Let's go forward. So after the static analysis was done, and we have to learn to the analyze that with debugging, and then in the safe environment you can just use the OOD command, and you will go to the you will load it to the memory first, and this is actually the library needed for you to analyze and being used by the application of the shellcode, and after being compiled, of course. And then after that being loaded, then you can do whatever you want in the analysis, and everything is there for you to see. And I will teach you how to use that kind of the environment to analyze. And these are the video in the fast forward. Then after you get the you can also use the information that you did before, and you put those comments in the specific parts again during the debugging, and then to make you understand about what kind of the operations is actually going on, and in which kind of register, and which register is doing what. And afterwards you can just aim for the stuff that actually can be used for you to confirm whether where is the exactly WinExec for in this case is gonna be in the AX register. So just confirm that, and I'll show you how. And after that, after this being done, we'll confirm it with some kind of the debugging, and there is supposed to be execution somehow. And after that, the program will continue to the exit process and until finish. So the next part, we are going to the second video, which is let's go to the slide first. We are using the other ways, which is using RVA to hash the function to names, seeking with a loop, and then match with a WinExec, and then hash. And then this is a pretty much operation using the hash, just like the message, the second, the mystery file that we analyzed before. And save it to the address to executable register, and then push WinExec arguments, which is cmd show integer, and ucmd line, which is contains of the calc.exe to the stack, and calling to the register to execute WinExec to execute the calc.exe afterwards. So this is the binary that being used for analyzing, and then all you can see is only the calc.exe over there. So you don't know about how it is being used to execute this calc.exe, because of WinExec is not being saved as a string, but we are using the hash operation for that. This hashing matching stuff is quietly oftenly being used by the Shellcode, so you have to understand this method too. And for this, we're gonna take a look to the video 007. Okay, here we are. All we have to do is execute this. This is only a preview, so I will explain about this video and how it is actually working. 005A sample. It is different with the numbering of the videos, and then this is the binary that's being analyzed here. And using the same methods, you have to make a preparation for the compilations. Let's skip that area. And then after that, you have the Shellcode ready and being ready for analysis, and it's becoming the exe file. So making the explanations, but one by one, what it is actually doing, like this. And afterward, I'm going to skip it. It is all over there in your archive directory, so if you want just to look about those comments, just access them, and then you can use that for your own any kind of the purpose that you want to use. And then yes, and we can check about how it works there. As per explained before, it's using the hash and what kind of the hash being used. This is actually the hash part, and actually what kind of the command that being used is written over there. And yes, afterwards the hashes is actually pointing to the WinExec, and the WinExec being executed afterwards by calling the EBPs here. It's quite a straightforward for this analyzing, and it doesn't have the quit command, so I'm not sure is it gonna be a very good way to do the coding though, but it's working. And further, it's about the debugging. So we are doing the debugging process too after it is being compiled and being statically analyzed, and we know more or less about how it works. And it is explaining with many kind of the help that I wrote under that. If having some kind of the explanations, it will help you to understand the videos after you seeing it. So it's quite easy for you to follow, and you don't have to deal with my voice also. And after that, this is the debugging guidance that will help you through the debugging process, and then will lead you about how to make sure about which kind of the calculations of the register. And another sample also being performed here. Two samples is being actually analyzed in the same time. And yes, the same way of the analyzing is being performed, different samples. And after that, this part is finished. And in this presentation video, you'll be expected to know about the WinExec executions, and there is another part of it which is will be explained in the video 008. In the video 008, you will have another ways to execute the something with a WinExec. In this way, I'm going to execute the CMD's, not called exe, but CMD's exe, a cell. And for that, the plan is still same, like we're going to use the WinExec to run the CMD, but through another workaround. Well, first we load the kernel modules, and then go to the init memory order and find the kernels 32 DLL, and using the module name hash matching, we are gonna put the desired naming functions into the memory and matching it through the name table in each of the library that being loaded according to the init mem order, and we'll seek the get proc address, this mistype, and save it in the edx, and we'll push the winexec cmd and exit process to the stack for that kind of operations, and we'll use the get proc address to run winexec, and to run for that winexec to run the cmds, and then afterward we'll do the exit process. We're not going to run this over here because of this kind of boring. It's the same kind of the process that you saw before. So we're going to skip that demonstration in that video, but the video is there, so you can see it here. Okay, I have to kill first the previous videos here, and here it is. If you run it, this is actually the one that I mentioned before. The size is a little bit weird, but it's there. So it goes like this. It has many kind of the analysis and so on, just like before. And in the end, will lead you to the debugging here, and afterwards you will be guided for the executions of this calc after being executed. And there are some trials and error over there, and then many interesting things that you can confirm through the debugging process and so on. Same as before, the telop will be there for my typings, explaining about the process that for you needed to be going through. So in here you can understand about what's going on with each call or name table being used. This is stuff that actually can be confirmed in the memories, and many kind of the guidance is needed, and then execute it again, and also how to use the there. In this part is we are trying to use rwin again in order to get to know about the get proc address after being sick. So after the process being sick is it will show exactly the pointer to the absolute address, which is not being used, but can be used for confirming whether the API that being sick is actually being found. So if we can compare the result of the rwin.cs for such API in the certain libraries, and then compare it with the value of the pointed or saved register for that API, and we can actually checking whether the shellcode is actually matched the desired functions. That's a quite important concept that are being introduced there. And after matching, it will show a lot of stuff. So I'm gonna fast forward this. The next is we try to understand about the modular concept of the shellcodes. It is provided with the example. The example file name is second 007, but the video name is different. The video name is video 009. So yeah, this is actually the modular shellcode. In this example, I'm using it. I'm using the downloader. Yeah, we try with the executing something. We try with popping some message boxes, and probably the most interesting things to learn in the basic one is downloader, right? So if you want to download something and to run it, probably you will need the shellcode. And if you need to know how the shellcode will work for that, this is an example for you. And yeah, the concept is quite the same. So first is you have to prepare the functions, which is looking into the init memory order to get any initial kernel libraries needed, for example kernel 32DL or kernel base DL, whatever. And you can seek another method to seek, which is using the Unicode module name length matching to the some bytes values. And this is a quite secure for seeking for the module name, not only matching for the strings, but you have to make sure about the lengths in the Unicode module name. And after you get the actual module name, either gonna be a kernel 32 DLL or kernel base DLL, and you can load the data needed for the CMDs and the URL where you want to save the payload into the stack. And you can use the load library A and URL download to file A, winexec exit process, and get the base address by hash matching functions for each of these APIs. And you can use simultaneously load the library A to load the URL mon DLL to exec the URL download to file A. And finally, you will use the winexec to execute notepad to view the payload, which is a text file, and then exit. It's a quite neat scheme. So this is the binary, so you can see the notepad is there, the whatever the name is in there too, and such kind of a URL is there, but you don't know what's going on, right? So this is actually the shellcode for that. It's not that big, it's around this size, so it's quite easy to understand. So the video is in the 009, but before we do the analyzing for the modular shellcode, which is quite complex operations, since register in the 32 bits is not that much. So but you have to understand about the stack frames, high and low addresses, especially related to the arguments that being used for the passing to one and into another functions. And if you are in here in this stack frame, so this is actually the old base pointer is having about this kind of the variables with this kind of the size. These are actually the basis. And then sometimes we are dealing with the stacks, you have to know exactly also about the high address and low address, that possibly the range of the stuff that can be actually being saved or operated temporary in the memory for the analysis purpose too. And for checking out of the which kind of the API being used for in each of the module name module that being loaded, for example, again kernel 32 DLL or kernel base DLL, you have to understand about this offset of the library file itself, and which offset address, and then what kind of the virtual memories that actually can be calculated to each from the each points. And then you have to know this in order to understand where the export table is and how to get to the address table, for example, after that, and go to the name pointer table and ordinal table. After you know about that ordinal number, it's not so hard to get the function matching, function name matching, and put this function address into the memory, and making a register to point to that function address too. This is actually the base that has to be mastered, both of them, if you are gonna deal with the modular shellcode. So example that we done before about the previous analysis that can be used as a reference of before we starting doing the modular, because of this is actually a bit of the modular that was teaching you about the using get proc address to run the API under another libraries. So you don't have to necessarily load library first and then you seek it again through that memory, but you can use this kind of the process, this kind of the concept too. And yeah, go to the demonstration afterwards. So I'm gonna switch to video, start with the explanations, and then go to the basic first. Different with the previous one, probably some of you are wondering why we have to go to the PEB. What is PEB exactly, for example, and why is it stuff that we need to know? So there are informations about that in the Wikipedia that you can understand about those kind of the operations. It has TIBs here, which is explaining you about the thread information block, and through the pointer of the part of the TIB, there is a pointer that leads you to the PEB one, and over there is an explanation for that. And these are the concepts that making you to understand about how to count each pointer and each address after one to another in order to get the REV table and go to the further details after that. Well, this is a know-how that being added before starting the demonstration for this matter, and it will explaining you again about this stuff, just to make sure that you have to understand those. And here we go. There is a sample for that. All you have to do is analyze that sample, reproduce it, and then try to, well, you are a little bit professional right now, so let's run it and testing whether it is working or not. And after you execute it, it will download and execute the notepad and showing it, and these are the files that being downloaded. It is a URL that making you access to your own local host. So all you have to do is try to run HFS exe that is provided in the examples or toolings folder, and put the s.con file inside of it and running it before you start this practice. So it will download and just popping up the s.con text file into consoles with notepad, and it will be safe in your default directory where the Shellcode is actually running. It's very safe. It's not malicious or anything. It is used for the making you understanding about how to download something through the Shellcodes, and then how we can making ourselves understand and making mitigation and analysis accordingly. Then we have to analyze that, well, as usual. Then it has a style of explanations also, so you don't have to be worried about not knowing about what I was talking about in the middle of the video. And there are plenty of the comment that you can see, and I really like to analyze the stuff thoroughly, so you can see in the very details. So this is actually quite a good many kind of the comment actually being implemented here, so you can see it there. And after that, these are actually the result, which kind of the module that actually being exists here. And in this part, it is also introduce you about how to analyze the modular binaries, modular Shellcode binaries, which helping you to operate faster, and it will you will be explained about the how to use the flag, how to use how to go back from the previous operations, to how to use the visual mode of the rad array, not only with a command line as per the beginning of the analysis that we are doing, and then several good tips with a visual mode will be introduced over there, and then how to change the name of the functions, and then how to make data can be shown as a text or can be treated as a kind of the definitions with opcodes and so on. So these are the results. So practically it's already analyzed by me for you, so you can just follow this video and doing it by yourself, and you will see about the what kind of the result. Comparing the result is pretty good too. This is actually the analysis result showing in the screen being dumped into the text file. We have explained this before too. So it's gonna be like this. So you will not losing the records after analyzing something. So it is actually making you more understand about how actually one shellcode is working, and then after you understand this shellcode is working this way, probably you will have a very sharp confirmation points to do while you are debugging it further in the dynamic analysis. These are actually the part that the key points that you need to confirm, and then they are quite probably not a straightforward kind of executions for the modular basis shellcode. It will call here and go back there, and after calling it will return it such kind of value in the some register, and then you have to make sure about that, and then after understanding that well, you can make a flow simplified like this. So actually this is how the shellcode is working, and then after understanding this, you can go to the debug based on this kind of the flow that how the shellcode is actually operated. So it's much more simpler to understand for you. This is the way I'm doing it in many kind of the analysis until now for the shellcode. So well, this is a way to do it, and then after that you're going to the debugging. Debugging is also the same. So going to the memory, you'll find many stuff over there. Go back to the analyzing analysis path that you are you already dumped it before, and then you go back to the binaries, and you will see some of the result, and go back to the basic again to understand about which kind of the to confirm which kind of register are using by saving this kind of the values and stuff like that, in order to understand the flow better. Then many kind of the telop is also being made by me, so you will not being lost, don't worry about that. And after that, how to use some breakpoints to confirm some stuff. So this is about how we need the WinExec operations, and then this is after being executed and so on. So it's gonna be there, and this is actually a quite good exercise for you to understand about how it is close to the reality, where most of the shellcode nowadays are actually being built through the builders, and these builders is actually making modular separate between the one module to another, so you can make any kind of purpose, just put them into some modules and compile it to one binaries and so on. So you will get used to the closer to the operational mode for analyzing shellcode with this kind of concept, with this concept of analyzing shellcode in modular stage. If you have interested with this kind of shellcode, I have many of them, so probably just contact me in the Slack for that. Remember, we're here to learn to dissect the shellcode and we are not allowed to use the shellcode for the malicious activities, and that is not the purpose. I'm here and you're here, and we learn together to make our world safer. So we'll go to the next part after this. So in this part of the video, practically it is explaining the same as per the previous part. We are having the tools to be set up. For the 64 bits is having a different kind of tools, especially for the Windows. We are having very different ones. For example, we will need the MinGW for the 64 bits to compile the binary in the Windows platform using the MinGW or the GCCs, and we will need also the Raspberry 2 64 bits versions, which is I'm using the Raspberry 2 version 5.3.1. And there are different templates to be used for the 64 bits. I think you know about what's the reason for this, because of it is quite tricky if you are still using the previous template with it, because it was designed for the compilation for the 32 bits. So for the 64 bits, I was using another template for the assemblies compilation for the shellcode wrapper, which is having a very good part of it. It has the part where you can seek for the shellcode if you lost it somehow in the memory, because it has a 16 bytes of the NOPs after the shellcode being processed. So all you have to do is seek them in the RAID array, search it, and in the memory, and then you just aim for the 16 bytes NOP codes, and you will see the shellcode actually resides in the memory. And there is also a interesting part, which is by default the wrapper for the assembly in the 64 bits is having the message box after the shellcode being executed, so you will be notified when it has executed successfully, or if it doesn't do anything, you will know exactly that the operation of the shellcode is finished by seeing the message box appear. And that functions of the message box can be enabled or disabled in the template itself. All you have to do is just to comment one line for that before doing the compilations with the NetWide assembler. And there is also rwin.python files. This is actually the script for you to seek hash of a certain API in the certain DLL files. All you have to do is pointing it to the which DLL or which directory of the library that you want to aim to ask about certain APIs, and it will telling you about the hash values, and these hash values can help you for analyzing stuff further. And we are also having this one, compile c.bat is a compile c, meaning that for the advanced class we are not using the code blocks anymore, but you can use that too if you want to use the code blocks. In my version, which is 17.12, is using the MinGW, which version GCC is supporting only for the 32 bits. And in order to use the code blocks with MinGW with versions of GCCs supporting to the 64 bits, you have to making settings in the preference of the compiler in the code blocks itself, and it has a thorough explanations in the video in about how to do that too. But that is probably doesn't need much. All you have to do is just use this batch file. This batch file is quite simple, so you can pick to compile any kind of the C codes, whether it's gonna be 32 bits or 64 bits, as long those two MinGW versions are installed in your system, Windows systems. And we are still using the same NetWide assembler 2.11, and this version is actually still valid for analyzing many kind of the circuit until now. And my used assemblies code are compatible until the NetWide assembly version 2.14. The recent one is 2.15. There are some changes about some macro and some commands, and some of the codes probably is not gonna work pretty well in the 2.15, and I haven't finished testing that version yet for overall my utilities. So this is actually the stuff that needed to be installed in the Windows version, and it has the thorough explanations in this video, which is explaining you what where to get there, and then how to load it, how to put those file in a certain folder, for example. And this is explaining about how the code blocks should be set. As you can see, it is mentioned about the parts, and then this is the batch file that I mentioned before. It is practically picking which kind of the compiler of a MinGW that needed to be run, and all you have to do is just enter the file name without the extensions, and then the program will ask you about the architecture, either gonna be 32 or 64. And it has another kind of the options too, which are these are the practice files and some templates to be used. And yes, this is the path of the MinGW, and the other part is you go forward, and then to see that the rest is practicing about to analyze shellcode through these new environments. This is actually the test one that we were making before. Right now, it is using the 64-bit shellcodes. It is working a little bit different, and it's using the template that is very different than before. So you have to see it carefully. The concept is the same. It's just there are some modifications, so I'm not gonna go into the details to any of these new modifications, because all of them are already included in the video. So these are actually the pop-up that can help you in the making the analysis successfully or not. And there is a demonstration also about the Arwin Python version, which is actually the stuff that being used a lot nowadays by the plenty of the malware analysts and it is useful for dealing with the shellcode. Then okay, hold on, I want to show you something. This is the one that I mentioned before. I put in purpose the this much of the NOP codes after the shellcode itself. Shellcode is supposed to be running here. This is for the test, so I'm using the assembly for the making the shellcode runs. And all you have to do, try to grab these strings in the radar array and you can use the how to grab the strings method that I introduced in the previous parts. So after this, it'll run, and then you can play with it and debugging it, and try to compile it and to test the environment to be run as per we were doing before in the 32 bits environment. And for the Linux, it's also running with 64 bits. It doesn't much making differences, but for the toolings, but the command line needed to compile is having several modifications, and we're going for that configuration. So these are some examples that for you to test. So this is the files needed. This is the directory that if you can see it, it is provided to also. It is provided also to you in the archive. And yeah, we were using this example before with 32 bits assembly, right? So if you want to compile this with 64 bits, you have to change all of the especially the register to the 64 bits, but AL BL is still resides, so AL is a part of the AX, so it's gonna be in the well, it's gonna be called, it's gonna be included in the RAX register, the far left ones, and so does the there are also BL and DL and can be used also, so you don't have to change those. And yes, practically this is how to test it in the 64 environment. This is the template that being used. And for the compilation for the 64 bits is gonna be a little bit different. It has this new hint for the 64 bits. So all you have to do is just following this or memorize that. And afterwards, it will be several demonstrations and testing that can be done from your side. So this is actually the video that can be used by all of you to see it carefully to set up your environment in the 64 bits for Windows and Linux environment. And now go back with to the presentations. Okay, let's stop this video and go back to the presentations. So the next part is about talking about the OS X shellcode. We're gonna do this very thorough from the setup to the analysis of the very interesting shellcode in the OS X environment. And thanks to Pancake for providing me a very interesting sample, so I can play with that a lot and show it and share it to you. So for that, we are having the OS X, I think no, this is post exploitations. Numbering is confusing. This is what we had before, number 11. Okay, here we are. This is actually the explanations about the shellcode, how to set up the stuff and how to use it in the OS X. In this case, I'm using the OS X Catalina. Intel version, not M11. For your information, we are doing the ARM shellcodes in the advanced class, and we are doing the MIPS and PPCs, and also some others specific CPUs used for the embedded versions in the advanced program. And you have to go through the this basic course and run this exercise by yourself first before you go to the advanced ones, because of not the knowledge about the shellcode or assembly that we worry about, but the way you operate the radar is really need time for you to master. So this exercise is helping you to actually getting know about this good framework for analysis. Well, practically it is compiled in the almost the same way, but it is having a different way to compile. Then you can check it further here. So as you can see in this command line, it is using the network assembly too, but for Mac OS X we have the different options, and we are actually using the GCC to link it, not using the LDs instead, and to link the object files to become binary files. And the result is a binary that we are seeing right now, and starting to be analyzed. So this is actually a very good exercise for you if you are having a OS X shellcode and you want to try it, and you can use these methods. And there are interesting ways, like where was that before? This kind of the strings is meant to the cell, but how the cell being executed, you have to see the rest. That's very good hint for you. And the rest, all you have to do is play with. So in the OS X shellcodes, it's not only having the way to build the environments or compiling it, and you can analyze those also in a statically way, and then execute it in the dynamic analysis with debugging mode of the radar program, and then you will see the very good result from that. In the debugging, you will see the values of these registers, and will help you to investigate what kind of the operations that actually is running. And then yes, you can see about the result of the what kind of the port being listening. And this actually will be a very good exercise for you, so please do this exercise very well. Then we are moving to the next chapter. It is an introduction about the advanced class. We are having two parts that in the advanced class that we would like to introduce you in these presentations. The first one is I'd like to get to any kind of the tools related to the exploitation framework, and then I took every shellcode that I can get from any kind of the environment over there, and analyze them to make me prepare for having or meeting those in the my daily basis. So this is actually the concept that you should try to. In this introduction, I'll use only one framework for that, which is a Metasploit shellcode. So in these presentations, you're gonna have to dump all of the shellcodes in the Metasploits, and you will pick some of them, and you have to build them, and then analyze them, and then try to regenerate the operations, and then see the executions of any kind of the possible outcome that can be done. You don't have to use the Metasploit shellcode for that, but you will need the source code of the Metasploit, and then you have to download it and pick up the shellcode and try to build them and grab all of the strings that being built and try to analyze in our way, like previously stated in the previous slides and videos. It will show you that what kind of the code that actually share over there. And some of them is having explanation, some of them is having a confusing explanation, some of them is having some comment like this. So if you see this code, it's actually being commented. So if you just use and compile it as per it is, probably it will not bring you any kind of a result. So you have to be careful about this kind of code. Make sure it is executable or not. You have to check it. And after doing that, you have to download them and then saving it to any kind of the platforms. Download this can be done from these sites. This is how it's actually being built. If you are having the Python, so it is you're pretty good to build them all. The command is there, and all you have to do is make sure that the code is making something, and then after that you have to modify it by yourself to make it work pretty well. And these are the shellcodes of the Metasploit. You don't have to download them all, but the shellcode parts is quite enough for this checking, and then you have to, as per shown over there, make adjustment for the code to make it run pretty well. And after that, you have to go to the compilations of the shellcode through the provided Python generations through the network assembly that has to be exist into your system. For example, this is a sample for the extracting the shellcode. So you can use these strings to make an analysis with our way afterwards. And you can use that for the 32 bytes or 64 bytes. It's having the same way. You can do that with your own ways. If not, then probably you have to dump that from the source code, and then from the source code you have to compile it one by one. But you have to be very careful that this shellcode is actually modular, so you have to really see, if you want to seek one file, probably you have to seek also which other file that probably needed or included. So you have to put them together, and then you can compile it by manually, as long as they are in the same path or in the accessible path according to your options or your likes or dislikes. And I think after you compile it, you can make any kind of the analysis with Radar. And yes, you can check that too with this, and you'll see that the calc exe is actually being executed. Calculator is running, so that the code was actually work in the Windows 10. This is Windows 10 latest version, and yes, and so on. So you can check any kind of the shellcode over there. I was checking in this example. I was checking about the single executions, and I was checking about the bind TCPs, and then I was checking also about the reverse shell. All of them are working pretty well. You can see it in this video for the more details later on. The other part is Linux shellcode in the process injection that we found in the malware's die during our operations in the helping people who are getting infected with something in the internet, especially the ones who's using the Linux servers or FreeBSD servers. And this is one case that actually quite interesting. The victim is using Debian 64-bit server, and there are multiple TCP 4444 communications traffic discovered by SOC, and SOCs keep signaling about these activities, but the malware scanner cannot find anything after the all of the files in the PC is being scanned, so it has to be resided in the memory. So at that point, we are asked to making investigations, and at that point, it was a hot forensics. So after understanding the situations, we made the regeneration about what had happened, and then this is actually the regenerations environment that being used for that case. So under receiving permissions, we would like to share this how we investigate this actually shellcode findings during the incidents, and so you can see about how the impact of the shellcode directly to the running surface, not only for Windows but for the Linux too. So these are the video for it. The video number is 013. So let's go to the 013 video. Well, the system is actually the Debian, and if you can see, these are the process. I'm for making it faster, so it runs 4444 with a program name dates, and then if you seek further, the dates is having quite weird operations here, and if you see it in the ls of f, it's having a two kind of the PIDs running, and if you see it in the process, it has two dates running, and the date itself is running from the temp directory. For example, this is actually a very good case, and in this video you will see about how we handled these injections, and how we actually doing the investigations in order to understand what had happened, and through the many kind of the combinations between the hot forensic and cold forensic, we found that there's actually a process injection is happening, and the attacker is actually successfully getting into the system and launching this process injections, and this is the way for any of you to handle that. It has like 1 hour for this video only, so please make sure you're don't forget to rest in the middle of watching those videos. We are picking up some shellcode which are interesting or modified with a specific purpose, and specifically aiming for the public cases. In this example, there is a shellcode like this. It is called Magneto. It is quite old, but it was analyzed successfully with a radar array at the time, and these are the results for that. So you can see it is loading the specific library, and it is using the WS232 DLL actually, and performing the connect sockets, and over here is try to connecting like 5 times looping, and getting several information from the infected environment. In this case is people's designated browsers, and then after that getting the username, and then it has several API being called here for making a callback, and connections were made by using the HTTP protocols, and there is a send. This is our actually the shellcode that being used to infect people's who are being online, and then making a callback to the some control center after the target has been compromised. So there are many kind of the shellcode also being shared, and then we are having much shellcode to share in the our training, our in-house training, and then we would like to expand the training to the more public levels. So feel free to join us in the advanced class of the shellcode analysis with the radar. And some handout in the FIR. It is related to the incident response mostly, and some forensics advice. And for the IR and forensic perspective, dealing with shellcode in the mitigations, I'm sharing the start points just to use the video as a recommendation for you to step forward. The next part is about the discussion on differences of the hot forensics versus the reproductions. I'm making it as a table here. This is for the hot forensics, and the other part is for the reproductions. It has several questions here, which is quite good discussion topics. You can discuss it with your fellows, and let me know about what you think about this idea. Rather for the shellcode analysis, how good is it? Well, this is for the hot forensics. So this is for cold forensics. For the seeking, sizing, if you are using the radar for the binary diffing, there are plenty commands that probably can be used, but it is really consuming in the memory for the hard drive. In memory, probably can mess up the other artifacts and the memory state too if you're not pretty careful. Probably the data will be that high, so the radar that is having really small memory space can be overflowed, and the memory state will be ruined. You have to be careful about the bin diffing in the live memories in the hot forensics, and I really don't recommend you to do that. Dealing with shellcode in the incidents, you will have to do this kind of the tips that probably helpful for you in dealing with incidents. And you can read about this later on, and then I hope this share can help you. And this is actually my playbook in dealing with the shellcode incidents or shellcode analysis. So it will probably give you some ideas about how to follow the progress of the shellcode for your own research too. First, it's about resources. These are the very important resources that you can seek for the shellcode. It has it in there, many things that can be found. All you have to do is open your browser and go to the Google, for example, and try to Google each word of it with a shellcode, and you'll find many interesting sites that can explain you much of it. And one thing that you have to be careful is, I go back to the previous slides. If you're accessing this slide, if you're downloading something, and if you're in the protected networks, it will raise an alarm. So you have to be careful, and you have to really be in the OSINT mode, for example, and using the very secure environment first before you're accessing this, or else you'll making another admins come into you and thinking that you are exploiting you are exploited with some things. And this is the example of the shellcode wrapper. This is based on the radar analysis that I was doing from quite a while. Well, practically these are the wrapper, and then these are the data that actually the shellcode is being saved in the memory. And it's not necessarily go to the um, entry points, but mostly if you are injecting something to process, and that something is a shellcode, it can be in anywhere, depends on the vulnerability sections. And if you are compiling it through for example GCCs or any kind of the C compilers, you will not find it in the entry 02. Probably you will find it in the main, and main will call it to some kind of locations to allocate the shellcode like this one. And the very easy way to do that is to use the net-wide assembler, and then you compile it in there, and you will find the shellcode exactly in the entry 0 or entry points. But you have to very sure that is being compiled and being investigated in the designated device or operating system environment that shellcode itself needed to be run. These are several interesting shellcode cases for you. The first is a double pulsar analysis. It is written over here. There is a Frenchy shellcode here. This is quite interesting. There is a rig shellcode and blue kip shellcode also. Those are very good writings, and I like it very much. So I hope you like it too. And these are the further analysis of the shellcode that you can seek in the internet. It will help you for the making analysis further, and to make you having more research in the area. Let's not use this knowledge to harm others, but let's learn this to save others. Yeah. And if you have any questions, just ping me in the Slack. Thank you very much.